All right, we're going to practice finding an image in a concave mirror. And if we find the image, it'll help us then describe the image. Where is it at? What does it look like? So these are called ray diagrams, all right, or ray tracings. You can see this worksheet's titled. And we are going to be doing concave mirrors, but they can also be referred to as converging mirrors because from the demo I did with the lasers, if they all come in parallel to the principal axis or kind of the horizontal line, they'll all converge then and go through the focal point. That's actually a crazy important idea for being successful with these, okay? So I'm going to jump right into it. So the first idea is we want to recognize that this arrow right here, this is the object. Now typically with mirrors, it's kind of easiest to just think of you, the actual person, as the object. But if you think of the flat mirror activity we did, the screw could literally be the object. So it's the physical thing in space. All right, I like to think of this as a person because if it has an arrow head, the head represents the head of a person, and naturally then the bottom of it would be the feet touching the ground. So this line right here is called the principal axis, but you can actually think of it as the ground and people standing on it if you want to with the object. Okay, so here we go. The mirror is over here. It's concave. You can see that a focal length was listed and the center of curvature or radius of curvature is double that distance. All right, so we're going to use the demo with the lasers to try to predict where the image is. You have to even go back then to 2 days ago with the flat mirror and think, well, the image was formed where the reflecting rays intersect. So we have to be crystal clear on which rays are the reflected rays. All right, here we go. Jumping into it, I'll color code it. You start all of your rays actually from the head of the object up here. So I'll make a dot so that's clear. And based on the demo, the first ray is always going to start off parallel to the principal axis because when we did that with the laser, we knew that once it reached the mirror, it would reflect, but it wasn't random. It actually reflected down and through the focal point of this mirror. So that's the whole reason we did that demo. I'll make a little note up here reminding us first ray, we always go parallel to the principal axis or ground. And then it should, with a concave mirror, of course, reflect down through the focal point. Draw it past the focal point too, because sometimes the images will form beyond that. Second ray is then a little different. So second ray, you can't go parallel again because you would then just repeat the same path. So you have to mix it up. If you think about it though, if shining a ray parallel always goes through the focal point, if you reverse that and instead aim it through the focal point first, it should then reflect parallel. And it does. So hopefully you can trust me on that. So the second ray, we're actually going to again start from the head of the object, and then we'll go through the focal point. Once it reaches the mirror, it then has to reflect and will reflect parallel to the principal axis, or what we're calling the ground. All right. Now, what I haven't done that I like to do is I always like to circle which ones are the reflected rays because, again, the image is formed where the reflected rays intersect. So the red's reflected ray is this one. The blue's reflected ray is this one. That's important because you can see there's a couple places of intersection. The intersection for the reflected rays is right here. All right. Now that's not the image though, because the image should look like the object. So if this were a person, the arrow, we should have an image that also looks like a person or an arrow as well. So we better have a head and feet and everything in between. So if you think about it, these light rays started from the head or the arrowhead of the object. So this location of intersection better represent that head as well. The other important location then is, well, where are the feet? Well, they're on the ground or the principal axis. So zooming in, they should still continue to touch the ground. All right, so if I draw that in, you see my feet touching the ground. And again, that means the head is here, but it's actually upside down. So this is my image. This kind of makes sense because if you think to demos, all right, when you're far from a concave mirror, you actually are upside down and smaller. All right, so filling in the blanks beneath, is the image upright or inverted? Well, it's inverted because inverted means upside down. Is it enlarged or reduced? Well, when we say that, we're comparing it to the object and mainly the height. So you can see that the height of the image is a little smaller than the height of this object, so it is reduced. And the last question, is it real or virtual? This is actually really important to us. These reflected light rays were the actual light rays. They are the actual light rays intersecting. So if you don't have to do any backtracing and it's the actual light rays intersecting, it's real. What that means is, yes, you can still look at it by looking at it in the mirror, but you can actually also project it on a screen. So if I were to put a piece of paper right here, and the light rays then came back to that paper, it would project that image on the paper, which, think about it, that's what we do with projectors. We actually project the image onto a screen. All right. So this worksheet, of course, you can try the rest. 3 and 4 will be very similar, so I think, or excuse me, 2 and 3 will be very similar, so I think that's good practice. 4 and 5, follow the rules that I've put up here. Go in this order, but 4 and 5, there's going to be a bit of an issue. So if you get to an issue, that's okay, but still draw the rays that you can. You'll get a decent way through it, all right? Good luck, guys.